Good morning, everybody. How are you all? This is Dr. Nandi. Today we are going to talk about inference on difference of independent two means of independent samples. So difference between two means come from independent samples. So let me share my computer screen with you. Difference between two means independent samples. In an agricultural experiment, the effects of two fertilizers on the production of oranges were measured. 16 randomly selected plots of land were treated with fertilizer A, and 12 randomly selected plots were treated with fertilizer B. The number of pounds of harvested fruit was measured from each plot. Following are the results. Fertilizer A, we have some numbers, and fertilizer B, we have some numbers. Are the two data sets approximately normal? Part A. Part B, if appropriate, construct a 95% confidence interval for the difference between the mean yields for two types of fertilizer. Difference between the means for two types of fertilizers. So first we have to check out whether the data, both sets of data come from a normal population. How do we do that? In order to test whether the two data sets are normal, put fertilizer A in L1, list 1 of TI-84, put fertilizer B data in L2 of TI-84. Okay. Then press second button, then Y equal to, which is the top key on the top left key on the top row, and then number 1. Okay, so second Y equal to, then plot 1, number 1, then select on and select the last type of plot. Put cursor on the last type of plot and hit enter. So it's flashing on the last type of plot. This is like that. Okay. This is actually a quantile plot to test normality. Okay. Press zoom 9 and you will see a straight line. All points fall on a single line going up. This is called a quantile plot to check for normality. If all the points fall on a single line, then the data set is normal. So we have checked out that the data set from fertilizer A come from a population which is normal. Repeat the process for L2. After selecting the last type of plot, change the data list to L2 by pressing second button and then 2, and then zoom 9. Again, you will find almost all the points fall on a single line going up the hill. L2, therefore, L2 data in L2 come from a normal population. Since we have proved by the quantile plots, because all the points fall almost on a single line going up the hill, all the data points for fertilizer A and fertilizer B come from normal populations. Okay, since both the data sets come from normal population, we can construct a 95% confidence interval for the difference in the means. So in that case, we will press the stat button to calculate the 95% confidence interval. We press the stat button, then test, okay, and then select 2, which is 2 sample t interval. Actually, we'll scroll down till we see 2 sample t interval. We do not know the population standard deviation, therefore we use the 2 sample t interval, okay? And the input should be on data. List 1 should be L1, list 2 should be L2, okay? And frequency 1 is 1, frequency 2 is 1, sea level is 0.95, pulled is no. That means we are assuming that the standard deviations of the populations of fertilizer A and fertilizer B are not equal, okay? And then we scroll down to calculate and hit enter. And the 95% confidence interval comes The lower boundary is 39.084 and the upper boundary is 87.207. Therefore, with 95% confidence, we can state that the difference between the mean yields mu1 minus mu2 will fall between 39.1084 and 87.21 pounds. Notice that both the parts endpoints, that is the lower boundary and the upper boundary of the interval, are positive, which means mu1 is always greater than mu2. That is, the mean yield of fertilizer A is greater than mean yield of fertilizer B. I'll stop here today. If you have any question or comment, please write me a comment and I'll get back to you as soon as possible. And please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll come back next time with another problem, another solution. Take care. Have a nice day and thanks for watching.